Hi, everyone. It's Tony and Rob here. We're the co-founders of Great Ideaz. And today we wanted to talk about a question that we hear of a lot of times. The question is, how can we make a claim that the Trellispark product is capable of eliminating 90% plus, evaporating 90% plus of the code that you would typically need to write in order to build a custom business application solution? And the thing that's really different about Trellispark is we eliminate the code. Unlike a lot of other platforms where if you have a no-code solution, the no-code solutions or the low-code solutions, they are often hiding that code. That code still exists. It's hidden behind a really cool wizard or some form of being able to allow the user to be able to create a user experience. But there's a lot of code behind all this stuff. With Trellispark, we're able to eliminate and evaporate a lot of that code. So here with me is Tony, and I wanted to just open the dialogue to Tony and ask him, how do we do it? Why is it that Trellispark is able to eliminate so much of the code that you normally would need to write?
Okay, so the answer is simple, is that we basically do not store information in tables and columns. We have one table called instances, and every single record is stored in a data agnostic format using XML and JSON. So that's the simple answer. So you want to know why that's eliminated 90% of the traditional code. So I'm just going to whiteboard out, essentially what's going on in a traditional application and why we've eliminated a ton of code. Okay, so if you excuse me, I'm just going to stop my video share and share the whiteboard instead.
Okay.
So the fundamental assumption when you're building an application, and I'm going to do a simple policy management application as an example. Okay, so I have a policy management system that I'm going to write.
Which we built in the past, so we have a lot of intimate knowledge around something like this.
Yeah, and if you think about, mostly how these systems work, you have a data layer. So essentially, this is where your database is sitting. You have some sort of business logic layer, and then a presentation layer. Okay, so at the data layer, typically got a database, right? Because, most of our record storage is put into a database. Now, if I'm going to create a policy management system, I'm going to start creating some tables that relate to policy management. So, for example, I might have a table called policy. Okay, so I've got a table called policy. That will have like an ID field, a start date, an end date, and then basically a ton of other fields in here. Okay, so I would need to have a table called policy with a number of different columns. Okay, and then to access that policy table, I would now start to write a ton of stored procedures. So I would want a stored procedure that would allow me to create a policy. Okay, and the T-SQL in here is essentially going to be an insert statement where I'm going to be inserting the ID, the start date and the end date, and I'm going to be having the values, which would be the ID, the start date, the end date, and so on. Okay, so I would have a stored procedure called create policy, which would have at its heart an insert statement. And obviously the parameters to this create policy are going to be the ID, the start date, the end date, and so on. Okay, and you can already see that we've got some fun issues occurring here already, right? So if I now add an extra field here, okay, so let's add a field here called city. Okay, yeah. I've immediately got a problem, right? Because if I need to add a field to my policy, what if it's nullable? What if it's not nullable? Oh, I've got this create policy stored procedure up here as well. Now I need to put a city on it. So I've got to go back and I've got to modify and update this code, all right, so that it now has city on it as well. So for the sake of keeping the diagram simple. Just going to remove it for now. But you can see, right, there's already a maintenance issue, right? If I need to add or remove fields from my policy table, I now need to start modifying my T-SQL.
And every time you do that, you're going to have to go through a QA cycle and lots of effort to make sure you deal with any bugs or issues when you write that code.
Exactly. And it'd be nice if you only did it once, right? But you don't.
Yeah.
Right. Because, you know, as well as having a T-SQL stored procedure to create a policy, I'm also going to need to be able to list policies, right?
Would be nice.
Would be good, right? In which case I'm going to need a select function that will get me the ID and the start date and the end date. And then there's generally some variation of a where clause, right? So, you know, it's where, I don't know, it's this branch, where it's this type of policies, where it's, you know, you pick your wheres, right? But the bottom line is that there's generally a whole bunch of list stored procedures that you're going to write to actually get the list of stored procedures in and out of the database. Okay. At the simplest, we would also want to be able to, let's say, delete a policy. Okay. And essentially, I'm going to have some SQL that's basically a delete using the ID, right? So I need a delete policy. I'm going to give it the ID and I'm going to delete a policy. Okay, great. So I can create some policies. I can select from my list of policies. I can delete a policy. Okay. The other thing I'm going to want to be able to do, obviously, is update a policy, right?
Mm-hmm. One of the biggest challenges in policy administration is the updates and changes.
Exactly, right. So essentially what I'm going to be doing here is essentially an update statement. So I'm going to be updating policy, set ID, end date, right? So let's say I'm basically extending a policy, right? Or whatever, okay? But again, you know, the thing is, there's not one, right? There's lots of the damn things.
Yeah. And they're time dependent and there are all sorts of things around that.
Exactly. And then the other thing that we might need to be able to do as well as producing, say, a simple list of policies so I can pick a particular policy, I also need to be able to read a policy, right? So here, again, I'm going to give it an ID as an in parameter, and then my out parameters are going to be my start and end dates, right? So essentially here, I'm going to be doing a select S and E from policy where ID equals, right? Now, it would be nice if I only had to write one of those, right?
Mm-hmm.
But the problem is, what happens in cases where I've got user experience that only shows me 3 out of 5 fields or 10 out of 15 fields, or you know, if I'm an administrative user, I can see these fields. If you're not, you can't, right? So potentially I might also have multiple variants of this thing in here as well, right? So even just the basic create, read, update, delete. Okay, I've got a ton of stored procedures that I'm actually creating for my policy. And all of those procedures are strongly typed, right? I need to basically be able to account for each of the columns in the parameters and the functionality of the stored procedure itself. Okay, it's just what it is, right? At my business object level, okay, I would create, let's say, a class called policy. Okay, because one thing that we want to be able to do is provide an abstraction, right? I mean, it shouldn't be the case that my presentation layer is calling or writing select statements directly against my database. That's just not secure. It's not a good security practice, right?
Exactly.
So essentially, I'm going to create a business logic class called policy, and it's going to have, you know, the create, which we'll call this. It's going to have multiple lists, which we'll call this. It's maybe going to have a bunch of deletes and so on, right? So instead of drawing lots of things on the things, you can see, right, I've got basically a whole bunch of things in here, okay? And for each of these things here, I've got a list of params, are the parameters that are coming into to this function. And inside here, I'm essentially mapping the params to the T-SQL. Okay, and then I'm going to basically examine and return the result. Okay, and I'm doing that for every single one of these things that I wrote here.
Yeah.
Okay, so that's just my class to access my T-SQL here. Okay.
Okay, this all makes sense so far.
So how do I expose that business logic? Well, for some older web-based applications, right, I can just write my user experience here as a server website. Okay, so this would say be a .NET 4 technology where the website is actually executing on the server itself. Okay, and the server itself could then potentially make a direct call to business logic. So essentially the business logic is being compiled as a separate library and included in my presentation layer. Okay, and on my server website I would typically have a whole bunch of forms. Okay, so if I'm looking at the forms, I would have a form that would allow me to create a policy. Okay, and that would have a form, it would have a bunch of fields on it, and then a button that's basically submit. And essentially this form here is applying the user experience. So what fields being displayed, validation at the client level, and so on. And what it's really doing is allowing the user to basically fill in the blanks here, submit the form here. So it takes the values off the form, it puts them in the parameters to the create, and the create then calls the T-SQL here, and the T-SQL here now updates the policy table and then returns the result back. Okay, so that's what my create is doing.
Now you're describing, I think you mentioned that this is more of an older style way of doing things. Is there a more modern way of doing that?
Yeah, but let me just finish working through this part
Sure.
of the example first, and then we'll do that. Right.
Yeah.
So I've got something here that allows me to create policies. Then, obviously I need to be able to list policies, right? So at this point, what I've got is another form, which is some sort of type table view. So ID, start date, end date, and then a bunch of other fields, where essentially what's happening is as I come into this form here, I'm calling my list stored procedure to get a list of policies that match the criterion that I've got here. Okay, and typically, again, I will have multiple copies of this form.
Yeah, and you could have lots of variations to that too, based on the workflow and the nature of what the business needs to do and the different users that are using the application. You could have all sorts of different versions of this.
Exactly right. So it's not one and done, right? There's lots of different forms going on here. Okay. Now,
Yeah.
Ideally, I want to be able to pick one of these things here and then read it. Okay, so read and potentially update. Okay, so at that point, I've got a form where I've got an ID that's been passed in. I've got potentially a different set of fields. Okay, and I've got a field that says maybe save changes. And for brevity, let's also put the delete function on here as well, just for kicks. Okay, and now essentially I've got a form here that's calling my read function. So essentially I click on here, I pass the ID down into the form. The form basically uses the read and passes the ID in here. It goes into the read policy, it pulls the information, drops it on the screen, and then the user can come in and make changes to that information and hit the save, which is then going to call the update function here, or they can hit the delete, in which calls the delete function here. And I've got a ton of code basically on that read update form that deals with, who is the user? Is this the Rob user, or is this the Tony administration user? Or is this the Alex customer service operator, right? Exactly. So essentially I've got multiple variants of this form, And each one of those variants has got a whole bunch of different UX logic on the form that basically says, well, you know what, this field is visible because the policy is in the in the draft state. This field is not visible because the field has not been issued yet. And so essentially, even on these read screens, there's a whole bunch of embedded logic in terms of which fields are updatable, which fields are even visible. And I've got multiple iterations of this form.
And I was going to say, even if you tried to collapse that into or consolidate that into a set of some like unique forms or specific forms, you'd still have all sorts of logic that you'd have inside those, embedded in those forms, to reveal or suppress different aspects of the page, right?
Exactly, right. And the question is, why do we punish ourselves like this, right? I mean, it's what we've traditionally done for like 30 or 40 years since we invented relational databases, and this is the standard traditional model of building a database based application. So the question that we're going to sort of like ask ourselves now is, well, how much code did we write here? Right?
And just to clarify, Tony, like, even if, let's say you were using some of these more advanced like no code or low code type platforms that are out there now, they would still have to write all of this stuff. Even if they had a wizard or something to be able to configure different aspects of that user experience, all this code would still be there. You'd still have tons of code behind the scenes that would need to be maintained and troubleshooted for any kind of bugs or defects or anything like that, right?
Yeah, exactly, right. So I mean, if you look at say something like Dynamics, right, they have a universal data model, a dataverse, which has got hundreds of tables with thousands of columns on them, okay, and a data structure that's pretty much doing this sort of thing, right? So you're not allowed to go and delete any fields off that core data table. You can add extra ones to it, right, but you're not allowed to delete them, right? If you're okay with the standard workflow, then great, everything's good. But if you actually need to do something different, then you're actually fighting the actual data model of the solution that's been given to you out of the box as part of the no-code solution before you can even get on to working on your own code.
Right? And to be fair, like, Dynamics is a powerful platform, but it's going to have to deal with this because this is the normal way that you would have to build this sort of stuff.
Exactly. So, let's sort of like think about what it is we're looking at here now. Okay. So just for one concept, just for our one policy concept, let's sort of like total some stuff up here a little bit, right? We've got one table. Okay. Typically, that table, those core data tables, can have tens of fields. All right. So, we've got one table and tens of fields on that table. Okay. Here, when we're looking at the T-SQL, okay, we can easily have tens of stored procedures for our code, right? We've got a basic create, we've got multiple lists, we've got a basic delete, and then potentially multiple updates and reads. Okay, so even a small application might have tens of T-SQL stored procs, that basically are accessing just the basic CRUD functions. This isn't the workflow. This is just the basic create, read, update, delete code. Okay. Right. We've got tens of stored procedures just doing that. Okay. In your class library. So again, we've got one class library. Okay. And there's typically a one-to-one mapping. So we have tens of functions here. Okay. Over on our presentation, we've got at least 3 and typically 5 to 10 forms. So if I'm looking at forms, I'm typically looking in the region of 5 to 10 forms. Okay, per table. Okay, so per object in the database. So
and Tony, just to clarify what you drew there, it looks like you're saying you have one table there on the left. Is that right? Or do you actually mean that for each table you've got tens of fields? But it looks like you have multiple tables, don't you?
One table, let's say, per concept, right? So in this case, the concept is policy. Okay.
Yeah.
So I would typically have a table for that concept, right? So one policy concept equals one table. That table with tens of fields and tens of stored procedures, each of those stored procedures typically having tens of parameters, each of those concepts typically having a business logic class, in this case my policy class, with tens of functions, each of which has tens of parameters that need to map to stored procedure calls with tens of parameters, and those business logic functions in turn being called by 5 to 10 user experience forms that are displaying different combinations and permutations of those fields to different types of users, given that the state of a policy will change over time. So a policy will start in, to say, a draft state. It will go through a quote state, a bind state, an issue state, and at some point it may go through a revision or an update.
Yeah.
Before finally actually expiring. Okay, so there's a healthy state transition associated with that, and at some point in this process there has to be a bunch of logic that's dealing with, well, this user in the bind state is allowed to push this button or fill in this field. Okay, and as you can imagine, right, there's a ton of code that's basically sat there, and that's before you do any actual workflow or work with the data.
Exactly. I was just going to say as well, even from the context of the number of tables, like to actually build out a full-blown policy management system, you're going to have a lot more than just one table. You're going to have many, many tables with lots of different concepts in order to map all this out and do all the business functions that you need.
Yeah, and typically, you know, for a reasonable size application, you may be talking a couple of hundred tables here.
Right.
So
that makes sense.
Like one table per database. It's potentially a couple of hundred.
That's typical from what I've seen too.
Yeah. And the reality check is, in a relational database, is that these things will be related with parent-child relationships, some many-to-many relationships.
Right, exactly.
You know, and essentially, you know, you start getting into the problem we discussed at the beginning as well. What happens when I start adding some extra fields here, right?
Yeah.
Because if I need to change the fields here, I now have to change everything to the right. Right? It's not the case I just dropped a field on here, job done. Okay.
Yeah.
I've got dropped a field on here, and now I've got to go through all of my T-SQL that's basically maintaining that row, all of my business logic to map that new field, and then I've got to consider the effect of that field on all of the user experience forms independently and individually. So, you know, essentially even making a simple change like dropping a field on a form is a non-trivial activity. And then once I've made that change, I've got to test the whole lot end to end to make sure it still works.
And for those out there that are not that technical watching this, you know, from a business perspective, this is what Tony's explaining is just highlights the amount of effort required to make changes after you've actually written tons of code, and now you need to modify or change that code. The life cycle that you have to go through and bug fixing and quality assurance testing and everything else is quite large. And this is why a lot of software development projects, especially as they get more and more complex, have a lot of challenges with the execution and delivery of the solution as it builds up and gets more and more involved. Your risks of having issues with quality control and everything else start to go up and up.
Okay, so now let's sort of like think about newer clients. So for example, if I was running this as a WASM client in a .NET 5 Plus environment, what would be different? Well, I would essentially decouple my business logic with a REST API that would sit here.
Okay, so this is a more modern way of doing things than what you drew above?
Exactly. And instead of having all of these blue lines calling my class policy here, this REST API would call the class policy and would expose basically a bunch of endpoints for create, list, etc. And the calls would come in here. So essentially what would be happening is that the forms that would now sit on a client's browser as part of a WASM client wouldn't be trusted with a direct access to the backend database. They would instead call a REST API on a server that the business controls, and that REST API would then call the policy class to do everything. And I've just added an extra layer, right? Because I've still got all of these parameters here that need to be mapped to these parameters here that go over here, right? So essentially what I've done is I've increased the level of complexity to actually build out the solution and added yet more code to build my WASM clients.
But what would be the benefits or the advantages of, like, why do people take this approach to decouple the direct connection from the presentation layer into the business logic?
A number of different reasons, right? One is if you're using a traditional .NET 4 solution, the forms are basically being created on a server in your server network, and then the actual page is being rendered on the browser, and you're passing a lot more view state back and forth. It takes a bit longer on the network, but essentially all of the rendering of the page is happening on one of your Windows servers, and the client is only displaying the page. If you're using the WASM client, then the actual client is rendering the page, is actually responsible for actually drawing the page in the client browser using compiled DLL, and it only needs to pass the data back and forth. So it gives you a much more reactive user experience. It's it's much more user friendly from that perspective. And the other thing is that if you basically build a REST API and you set the user experience up so that it can run as, say, a WASM client, then you can also potentially look at rendering this thing more effectively on other devices, so mobile applications, desktop applications, and so on. So, there are benefits into client-side .NET 5 plus technologies, and maybe more reactive user experiences, but instead of actually having the business logic embedded and talking to the database type.
So really what we've done here is we've increased the or improved the performance and the responsiveness of the user experience by doing something like this. And when you're talking about a WASM client, like I think we're talking about examples of things like .NET 5 and .NET 6 in the future that are utilizing that kind of technology.
Exactly. So this would, say, be like a Blazor client or a hybrid Blazor Maui client running on a mobile device, right? And the cool thing about that is that the user experience rendering is happening on the client device. Okay. We're only passing the data that we need back and forth. We're not passing information about the user experience and how the user experience is being rendered. It's just the record going back and forth. So the network traffic is a lot lower. We've distributed a lot of the processing to the actual client device, which also means that the backend then becomes more responsive and easy to scale, right?
So if you build
really reasons for doing this.
And so if you build this right, if you engineered this right, and you actually architected a way of building something like this, which, obviously there's a lot of knowledge and experience in order to do that properly. But if you did engineer this right, you could have a rock solid, highly responsive, highly reactive user experience for your business users by doing
exactly.
it. Okay.
Exactly. And this is, essentially the core of the Trellispark solution. But I mean, essentially,
another example,
that we're investigating here is, why did I eliminate 90% of the code? Right. So let's look at how that maps to Trellispark and see where this code, all of this code basically now will disappear, right?
Okay, so now you're finally after all of that intro, now you're gonna finally answer the question, right? So why is it that we can say that we eliminated 90%? So what are you doing differently here? This is what you've just explained up to this point is the normal approach, or I guess normal approach to building applications, where pretty much everybody else out there is doing that. What are we doing differently with Trellispark?
Okay, so Trellispark, fundamentally, what we're doing is we still have a relational database, right? That's not changed. Okay. I am now introducing a table called instances, which has two fields. Well, two sets of fields. It has basically a bunch of metadata that describes what this particular record is, and it has an XML fragment that contains the actual data. And there's a ton more stuff, but I'm just going to keep this simple to answer your why did we get rid of 90% of the code question.
Okay.
My instances table now needs a basic set of functions. So I need the ability to create, update a record. Okay, and I am basically passing XML and let's say an ID to keep it simple. I need a way of selecting or list, let's call it the list function to keep our terminology good. I need a list function with where clause parameters. I'm going to need essentially the equivalent of a read, where I'm going to give it the instance data and I'm expecting to get the XML out. Okay, and I also want a delete. I'm going to give it an ID and I'm going to take the record out. And there's a lot more complexity that sits behind this, right? But first and foremost, right, what's happened is that there's no policy table anymore.
There's no policy table.
There's no policy table. There's a table called instances, and one of the sorts of records that the instances table stores is policy. So I've already eliminated the idea of one table per concept. So I could draw a line through this and say, you know what, that doesn't exist anymore.
So, and obviously, I think you just raised a gazillion questions for folks that would be listening to this video. But in a nutshell, if you're saying there's no policy table, are you saying there's no anything kind of table? Like, are we saying that this could be, I don't know, a customer table? It could be anything? Like, why can we eliminate the policy table completely or unilaterally from this design?
Because what we're saying with the instances table is that the instances table stores a data agnostic record. It doesn't matter whether the record is a policy, a vehicle, a driver, a payment, a claim, whatever. Okay, it's irrelevant. The instances table is just storing records and it doesn't know or care what the record is.
That's a big
ID and metadata and an XML fragment that represents the data of the record.
Okay. Now that's obviously big, because if you're doing everything agnostically and from a data perspective, then does that mean that everything here is generic?
Everything here is generic. I don't need 100 different creates, because I'm not creating a policy, I'm not creating a customer, I'm not creating a driver. I'm creating a record where all I need the ID of the record and the XML that represents the data of the record. And that's also why I can merge the create and update, because if the ID doesn't already exist, I just need to insert it.
So then, to be clear, there may be some complexity in the underlying elements around how you've designed and architected this whole piece of this, and this is what's part of the core components that make up Trellispark. So there is complexity in this, but once you've done this and implemented this in this generic kind of structure, you can reuse and repurpose this a million times for a million different purposes, and it would always be the same code executed. So this would be rock solid from a quality assurance perspective, because it's constantly used over and over and over again, and you never need to change the underlying architecture and design of this solution. Is that right?
That is absolutely correct. This is essentially what we will be describing in a few minutes as we look at the dynamic user presentation layer as data-driven application design, true data-driven.
Very cool.
So what we've done here is, as I say, we've basically broken the link between tables and concepts and fields and elements. So what we're saying here is it doesn't matter what sort of record we're storing. It's represented as an XML fragment, so I can store any sort of information here. And it doesn't matter if I change the fields, right? So my problem that I was describing earlier with adding a city field to my policy is now no longer an issue. right?
So wait,
Records that
hold on a second. So I just want to pause there for a second too. So if you don't have to, so if you wanted to, let's say you wanted to replace a field and use something else, or you wanted to add like another 20 fields or something, are you saying that this could be done at will and it's not gonna cause any other code changes for the rest of the application?
Correct, because XML frankly doesn't care, right? So when we're talking about moving data to and from the database, which is the discussion we're having at the moment, replacing that blue code above,
Yeah.
right? The fact that it's XML basically means it's any combination of any fields. If I want to add city fields, then I can add a city field. If I want to add a field for a geolocation, I can add geolocation data. And I can do that at will. And fields that already existed that didn't have a city field just won't have a city field. And then when that field is displayed going forward, then we would be able to see, oh, look, now I've got a city field, but it's empty for this record. Do I want to fill it in? Okay, great. Probably be a good idea to fill it in. And now I can save it and the record's updated.
So I guess this is another reason why we say that Trellispark is an extremely sustainable architecture in software development terms, because if you can do this way, and let's say you actually launched your application into production and now you needed to make changes, or you needed to pivot from a business perspective to do something totally different. Let's say you're doing policy administration right now, but now you want to introduce claims, or you wanted to introduce, I don't know, some other like auto permutation that just simply doesn't fit the model. Maybe you're doing farm insurance now that's totally different. You could do that. You could do those kinds of changes, and it wouldn't break anything that you've already implemented in production.
Correct. Well, that's like a whole extra video, right? So
yeah.
We could spend another hour just talking about that, Rob. And I suggest that maybe that's the next video.
Yeah, let's pause that one.
As I say, I mean,
keep going, Tony.
Focus on getting rid of the blue. Right? I don't now have tens of stored procs. I have one generic create, update stored proc. Let's call it save. I've got one set of list stored procs, one read, right, and one delete. Yeah. Okay? I don't have tens, and I don't have to multiply that by the number of tables, and I don't have a ton of parameters that are constantly changing, and I go from one to the other. In this layer here, I just have a logic class for essentially the core CRUD, which essentially calls, let's call it save, read, list, delete. Okay. And again, they only have a single set of parameters. There's one copy of this. There isn't one copy per concept. There is exactly one copy of this code that will never change, right? That's part of our core solution that's implemented using all of the IP we've developed over the last decade in terms of, optimizing this stuff. But there's one set of code. It never changes. You, as a developer, would never have to write this. Right.
And our clients can benefit from many years of pain and suffering to make sure that this all works well, right?
Right. And then, because we're basically building this only for modern APIs, we have a REST API here that effectively is providing the CRUD endpoints.
Yeah.
Okay. That basically map that. And again, all of this green code is already written for you and is a small volume of code that's been heavily optimized to perform its function very, very quickly. And it's all there. It's all actually working. Okay. And that's really cool in and of itself, right? Because I've just eliminated all of this blue stuff in these two columns on the left hand side, right? And we said, great.
Yeah.
We're going to take the assumption that we can create data agnostic record storage, that I don't care whether it's a policy, whether it's a customer, whether it's a driver, whether it's a vehicle, and I have to write all of this blue code on the left and center columns. I can replace all of that with essentially one instances table that sits here that has a basic set of stored procedures that provide my CRUD operations on that record in a completely agnostic way that I then expose through, again, a very simple business object, my logic level, and exposed through a REST API, and then I'm going to want to do some presentation. And then we said, well, if we were so successful in knocking out and eliminating code using data agnostic storage, is it possible to do data agnostic presentation?
Yeah.
Okay. And the answer to that question is absolutely, right? Because if we're basically saying it doesn't matter what sort of record we're storing, why should it make any difference what sort of record we're presenting? Is it possible to effectively code in a user experience data model enough information about the XML that we're getting from the database to dynamically draw the page? And the answer to that question is absolutely yes. So what we do over here is something called dynamic page generation. And what this enables us to do is when a user requests a page, okay, so I'm a user here, and I say, I want this particular page, right? I can use something called a form definition to say, well, what sort of page is this, right? So this form definition is saying, well, it's a policy, okay? And then in my form definition, I might then have a set of field definitions that say, these are the fields that I want to put on that page. Okay, and as part of that data description, okay, I can take into account the roles of the user, the state of the object, okay, and other custom conditions to say which of these fields on this form are visible, which of the fields on this form are hidden, which of the fields on this form, are read-only, right? And essentially what we're doing is we are basically taking this idea of form definition and we are baking it in to our read functionality here. Okay, and the reason we bake it into the logic on the CRUD is that we want to make sure that when I transfer data here, that the only information that I transfer here is information that the client is allowed to see or modify.
So I just want to ask a couple questions around this. This is very, very powerful, very interesting. And when we talk about the Trellispark dynamic page generation technology, how is this similar or very different than a low-code, no-code type of wizard to create a user experience?
So essentially, a low-code user experience is dragging existing fields from a data model onto a form, putting them in a particular position, and then that is good to go, right? I mean, essentially, that's what a low-code solution is trying to do, and it's calling its equivalent of the REST API to get the fields and put them on the display.
Right.
So, in many respects, it's a way of designing a user experience by defining and moving fields onto a form
Within the constraints of the box. So like whatever they've done and in creating that user experience, you're within obviously the limitations of what the box will allow you to do.
Exactly. But I think what you'll find is that the dynamic page generation technology that we've developed is actually way in advance of what's available on most low-code, no-code solutions. And again, we can do another 1-hour presentation just on that, right? Because that in and of itself is a subject worthy of discussion. But what this means, okay, so, just keeping it as a high-level summary of why I've eliminated all of the code in blue, is that I don't need to create a separate set of forms to deal with policies, customers, vehicles, or everything else, right? So I've got one dynamic page generator that will fit inside a WASM client for a website. And I have replaced all of the repeats of these blue forms on the right-hand column. So again, just to actually get data out of the database, to be able to display that data, update that data, put it back in the database, using a very complex set of authentication requirements around, what can a particular user actually see and do and touch. We built that into a data-driven solution. So again, you can modify the underlying data model here, and you don't have to write any code. So here's where it's really cool, right? Is that if I want to add a city field to the blue code, I have to go to my policy table, I have to add a city field, and then I have to update that table. And just doing that might actually be complex, if it's not nullable, right? Or if it's, got this business rule on it. I then have to go through all of the layers of the blue code and make the change, right? So all of my store procs, all of my business logic, all of my forms now have to take into account whether the city field is being displayed or not. And then once I've made that change, I have to recompile all of this code and make sure that I got all my types correct, that I didn't spell it wrong, that my capitalization was correct, and so on. And then I have to go and do a bunch of testing to make sure I didn't break anything when I did that. Okay, and that, as you can imagine, is a lot of work. And one thing that we see in practice is that people are always trying to add extra fields to tables in systems, right? It's one of the biggest sustainability issues.
And no organization is stagnant. No organization is just going to sit and do the same thing forever. There's always going to be changes. And one of the biggest challenges that we see in the market these days is, and for just about any industry vertical, I mean, the pandemic really spelled this out in spades, but the drive for change in businesses is just accelerating. And it just seems to be getting faster and faster throughout time when it comes to how businesses need to respond to changing technologies, changes in their industries, et cetera. So this is, when we're talking about business applications, we need resilient business applications. They need to be sustainable. They need to be able to adapt and change as business demands change.
Okay, so let's consider this now then. Okay, so we said if we add a city field to the blue, the traditional model, we're basically making a ton of changes. Okay, we're potentially changing the table, we're changing tens of T-SQL store procs, tens of functions in class libraries, potentially tens of functions in the REST API. We're changing basically a whole bunch of code in forms. What happens down here in the green model? Well, we would add an extra row to our field definitions to say, I now need to add a city field. Job done. It's the first change. That's it. Job done. I've now got a city field on my policy object. I don't have to worry about old policy objects because the rendering will still work.
And just to be clear, that would be, for lack of a better word, more of a configuration exercise for someone using the Trellispark platform, because they're just going into the dynamic page generation form and adding a new definition for a field.
Yeah, exactly. I mean, they might spend a few minutes doing that and moving it around and changing the labels and tweaking the look of the.
But you're not writing any code to do that, though. You're not writing any net new code or anything, right? Like that. And actually, the way this works, you're not writing any code because it's all generic.
Exactly. So you've actually achieved no code. This is a real no code solution.
That's huge.
That's a data model, and it's job done.
Right. So for that example that you just gave, it's not eliminating 90% of the code. It's literally eliminating all the code.
Yeah, and that comes back to the question you originally asked, right? Why do we say we eliminate 90% plus of the code?
Yeah.
Okay. So again, looking at applications that we've built over decades, probably 90% of the code is just the functions we've illustrated in the green and blue here. Okay, it's putting a set of data on a screen. When we create it, it's putting it into a database. It's getting a list of policies, that the user can actually interact with. It's editing, updating, and deleting that policy and putting it back. And that's what 90% plus of our application code does. Okay, and I've not really met a ton of applications that wasn't 90% of the code there. Now, the other 5-10% of the code that exists in applications is where you actually do something with that data, right? Where you perform workflow on that data. Okay, so I take a policy out of the database and I issue it. Okay, so
right. So you're changing the state of the policy to issuance or something like that.
Exactly. And again, part of what we built with Trellispark, because we built a state transition model into our form definition, a lot of that is automated as well, right? But there's always going to be stuff where there's actually some code, some business logic you're going to have to write that says, when I issue a policy, I also do X, Y, and Z. Okay, and that doesn't really change, right? That would exist in both the blue and the green, right? So that's where, there really is custom code that still needs to be created and managed. And that why we can't claim that we eliminate 100% of the code, because we don't, right? What we do eliminate is all of the code for the create, read, update, delete. And as I say, when you actually look at, the hooks that we built in to allow customization of the Trellispark framework, you'll see that there's lots of hooks for basically customizing any aspect of the user design and integrating any workflow model into the solution. So those are subjects for future videos. But essentially the claim that we're making, did we really eliminate 90% of the code? I think the answer to that is an unequivocal yes, we absolutely did.
Well, that's awesome, Tony. Thank you so much for walking through all of this and explaining exactly how this works and why we make these claims. I hope the viewers that have been watching this video learned quite a bit and enjoyed the discussion. We're always open to people reaching out to us and asking us questions around this and challenging us around what we're describing here. But this is a good example of explaining a lot of the heart of what we have within Trellispark and why we think it's so powerful. To learn more about Great Ideaz products and solutions, visit greatideaz.com. That's Great Ideaz with a Z.com. Thanks.